When it comes to butane, you have a longer chain and a higher molecular weight. And of course, that means you have more C-C bonds that can rotate, but you have to look at them one at a time. In this case, here's butane. It has this ball and stick model. The question is asking here to examine the rotation at the C1 and C2 bonds. So if you were to number it, let's say this way, you would say this is 1, 2, 3, and 4. Of course, you can number it the other way, but we're just going to begin from the left here. Now, when you look at it here, you have to look at it right here. Imagine you're looking at it. This is your eye, and you are looking at it from that angle. And the only way you can represent this, and you really have to use your visual skills very, very well and effectively, is if we have that circle, imagine this is our C1. Now, what's up here? You have a hydrogen that's up. You have another hydrogen and a hydrogen in the back. So this looks like the Mercedes sign if you're looking at it this way. So it would look like this. Right there. Now, what's happening in the back? So we'll call this C1 so that we remember. Here's our carbon 1. What's happening in the back? That's carbon 2. Well, let's see what's attached to it. So again, for the first one, we had 3 carbons. Mercedes sign. This is up. This is this one coming out towards you, and this one is in the back. Well, you have 2 H's. You have an H there and an H there, and look what else is now attached to this carbon, to that circle. You have an ethyl group. This is an ethyl group. It's a CH2, a CH3. Here's a CH2, and here's a CH3. So you have to include that. So that would be either you can write down the whole thing, or you can write ET. Either one is acceptable. So I'm going to use a different color so you can see it. So I have 2 H's. And of course, what's down here is this CH2, CH3. So again, in the back is C2, or again, this circle right there. So this is a staggered conformation. The angle is 60. So this is staggered. And of course, it has the lowest energy. Now you should be able to draw the eclipsed version. You need to practice on this without a doubt, so you don't simply learn how to draw this from day one. So let's now spin. We can spin either the front or the back. It's easier to spin actually the front because you have, again, just H's on it. So in this case, we will keep the ones in the back the same. Let's use the red here. And in the front, we're going to, again, tilt this at an angle. Right there. Again, not the best picture. It's because this software is not really helping me draw it, but you can see that this is a staggered. So the angle here is, the angle is 0. And this is eclipsed. And that would be the highest energy due to the torsional strain. Now let's look at what if you spin around the C2 and C3. So it's done for us here, luckily. So we're now spinning C2 and C3. Now it's what's most important about this. Students generally get this, really, they know how to master the Newman projection, how to draw it. The only thing is they sometimes forget to spin at the right angle. So let's look at the right angle here now. If I erase this,
upside.
So if you look at this, you have 2 between C2, C3, so you're spinning right there. You have a methyl. You have the 2 H's on this carbon right here, C3. And you also have the methyl. Here, you have the 2 hydrogens, and you also have the methyl. So you're no longer, again, looking at it from this way. You're looking at, again, the spin between C3 and C2. So you would actually kind of look at it this way. Here's your eye. Your eye would be looking at it this way. So here it is. We get the 2 methyl groups. Again, we will need to number them so you can see it for at least the first time. So we're going to say that this is C2 inside, and of course outside is C3, or the one in the circle right here. And this should make sense to C2. Look at the hydrogens, they're pointing to the side. And then you have, of course, right here, you have the methyl group is down. Here it is. That should make sense. Up, here are they, 2 H's, and this is the methyl, it's right here. And of course, in the back, you have the 2 hydrogens down right there, and then the methyl group up. So this one now is a staggered. You're right to call it that, but it's actually has a name for it. Now we call it an anti, simply because now we have 2 substituents. We have the methyl and the methyl. So this is the lowest energy conformation. And the reason why is because you have 2 large groups on this molecule. In this case, the 2 methyls, those are anti to each other. Those are opposite to each other. The other ones now, of course, when it spins, it becomes eclipsed. But now there are 2 types of eclipsed. You can have an H eclipsing the methyl group, or of course the methyl groups eclipsing each other and the H's eclipsing each other, like in this case. But let's look at intermediate. What happens? Well, we have one that's called gauche. Gauche, that's how it's pronounced. It's a German word. And it is basically when you have them 60 degrees apart from each other. So when you have those methyl groups 60 degrees apart from each other. So if you look here, this angle is a 60-degree angle between those 2 methyl groups. So this is where we say that the 2 largest groups are 60 degrees from each other. Now, the worst one is when they are eclipsing each other. This one is the highest in energy. But we need to understand why this is more or higher in energy than simply another eclipse. You probably guessed it that these two large groups are simply too close to each other, or they're eclipsing each other. So here, this is the highest energy conformation. And then we would show you here that the last ones, of course, like right here, this is a gauche, just like the first one before. And this one, this is another crystal. We're actually concerned with 3, or I would say 4 of them. This one, the first one, the third one, the fourth one, and the fifth ones. The other ones are, of course, eclipsed, but they are not as important. We will say that all staggered conformations are not equal in energy. So they're not all equal in energy. All staggered conformation with the larger groups right here, 180 apart from each other, they're called anti. So this one is called anti, 180 degrees away from each other. This is 180 degrees. A staggered conformation with the two larger groups 60 degrees from each other is called gauche, as I just explained to you. It's still a staggered, but it's gauche because these two large groups are 60 degrees away from each other. The anti-conformation is 0.9 kcal lower in energy than the gauche conformation because of something called steric strain. So you have a second type right here. Steric strain, or sometimes we call it steric hindrance, is an increase in energy resulting when atoms are forced too close to each other. So you have a cloud of the atom cloud and another atom cloud when those do not like to bump into each other. That would be, again, an electron cloud, an electron cloud. This is steric. Now, this language is very important. This language is very important. Steric will be used all the time in this class. Sterically hindered, or steric strain, etc. So that's, again, what's happening in here. So there's another view where we actually now look at it where it's plotted this way. So if you look back and see what happens, the lowest, the one that is with the lowest energy is, again, your anti right here, the one that is anti. Two methyl groups are anti. Look at how low the energy is. Of course, when they're now eclipsing there's an eclipse conformation, the energy goes up, but that's not the eclipsed with the two methyl groups. It's an H with the methyl group. Now it goes down to the gauche when there are 60 degrees at a 60-degree angle. The energy is higher than the anti, the staggered with where the two methyl groups are 180 degrees, but it's not as high as this eclipsed version. However, look at the highest in energy one right here. This is when the two methyl groups, again, are eclipsing each other. And of course, 60-degree angle. And you have now another gauche conformation. It's as much as that one. They're pretty much the same thing. Eclipse again. And of course, it goes down, goes back to the anti, where it's actually the lowest in energy. So again, this is the lowest energy. So one last thing to say here about that is that if you look up right here, here's why this staggered right there is the worst conformation in terms of energy. If you notice here, these two methyl groups, look how close those hydrogens are. So these, again, that's the cloud is simply, the electron clouds are bumping into each other right there. They are too close to each other. So here we say the two methyl groups, or two methyls, too close. And that's what we call steric strain. So gather your thoughts about this topic. It is not an easy topic. We totally understand that, but we just think about it, keep thinking about it. You are, when we meet next time, you will be given an example and you have to actually draw you would have to actually draw multiple of these. So you would be asked to draw at least one anti, the two gauche, and the eclipsed version. And of course, be able to tell which one is the highest in energy, which one is the lowest in